Quiz. Here's a quiz. Quiz. We have a 3-meter long a wire 3 meters long, lying on the x-axis. It has a nearly uniform charge. The electric field at a location negative 0.03, negative 0.020 meters. So this little x right here, it's not to scale, but that gives you the observation location. The electric field there is 0, negative 1.2 times 10 to the 5th, 0 newtons per coulomb. What's the total charge on the wire? Okay, two big popular answers, answer 7 and answer 3. 7 is correct. 7 is correct. 7 is correct. Now, you have to understand a little bit, you have to understand a little bit about the approximation here, right? Because the observation location is at x equals negative 3 centimeters, positive 2 centimeters, 0. But the rod is 3 meters long. Okay, so first of all, can we use the approximate formula in this case? Sure, that's no problem. All right, so we're going to use this for our electric field magnitude. Now, the direction, you notice the direction is pretty much straight down, right? Because the electric field is pointing in the negative y direction. We're at a location here. Remember we showed the program where we visualized the field of the rod over the entire length. We said that if you're close enough and you're near enough the center, you can get away with saying that the field is approximately pointing radially away, or in this case radially toward the negatively charged rod, radially toward, even if we're not right on that center line. So the electric field, and I'll just draw it, even though the arrow goes through the rod, that's okay. Electric field's pointing that way. And then what is this distance? And you got to be, again, careful about how you interpret what these symbols mean, because sometimes they're doing double duty. This R is what distance? The distance away from the wire, but from where? Is it from here to here? No, it's not. It's the perpendicular distance, right? It's the distance. It's the shortest distance from the wire to the observation location. This is what we mean by R in the case of the rod or a cylinder or something like that. Okay, so I think number 3 was taking that as the distance, right? Is that what people did for number 3? Yeah. So that, watch out for that. Okay, so you have to interpret what these symbols mean in the case of the rod, because remember we worked it out. When we first worked out the case of the rod, we called a distance along this center line y, and then we just said, well, because it could be anywhere, not only on the y-axis, but maybe on the z or somewhere at random, we're just looking at the perpendicular distance away. And in this case, that would be the distance of what? What would be R in this case? 0.02, right? It's 0.02 meters, okay? So plug in, then it's just solving, right? I mean, just using the algebra, you have Q would be equal to the electric field times R times L divided by 2 and divided by the constant 1 over 4 pi epsilon 0. Plug in R equal 0.02, L equals 3, and the value of the electric field and the constant, and we'll come up with answer 7. Okay, and you know it's got to be negative because it's pointing towards towards the rod. The electric field is pointing towards the rod. You know it has to be negative, and answer is negative 4.0 times 10 to the minus 7 coulombs. Okay. Questions here. So I mean, the algebra, the number crunching is not really the tricky part. The tricky part is interpreting what the symbols mean and interpreting how the field actually behaves when you're near the center and very close to the rod. Okay. Questions? Okay. They might. Okay. I don't consider this terribly tricky. I think this is more a question of understanding how the fields behave and understanding what the symbols mean. Okay, that's not tricky. That's just the fact of life. That's something you have to know. Okay. Okay. All right.